Welcome everyone. What an exciting time. Our second Lunch and Learn for our Australian Architects Declare. And today we're being hosted by the fabulous Supply Chain Sustainability School. But first I would like to acknowledge the traditional custodians of the land on which we meet and pay my respects to their elders, past, present and emerging, and to their immense wisdom and resilience and perseverance and generosity in everything they do. So without what we're going to do today is, first of all, Hayley Jarek is the CEO of the Supply Chain Sustainability School, is going to give a brief introduction to what the Supply Chain Sustainability School is about. And then Caroline Noller is going to present our guide to embodied carbon. And then after Caroline's presentation, Professor Prasad is going to put that into a little bit of context around a book he's writing on a whole carbon, not just embodied, but operational carbon, a whole carbon guide. So we'll end on that, and then we'll have questions and answers later. The lunch is meant to go for an hour. Hayley and I and Daya will be here at the end to gather any questions, and if you can put any onto the chat, then we can, any that we don't get to, we'll get to later and get back to you. So on that note, I'll hand over to Hayley, and thank you very much for hosting us today.
Oh, you're very welcome. Let's do this again sometime. It's been quite enjoyable setting this up, so it's lovely to have you all here. So all of you would have registered for this event at the Supply Chain Sustainability School site, and many of you might have jumped in and thought, who are you, what are you, why are we logging in and creating accounts and logging in for events on this site? So I'll give you a bit of a background. So here we are. We're a not-for-profit organisation that is set up to offer free education for anybody who wants it within Australia and New Zealand. We license outside from the Supply Chain Sustainability School in the UK, so we didn't create it from scratch, but we've copied their model. We've been around for about 6 years, started in building and construction, and now we're branching out into other industries as well. The reason why all of the resources on our site are freely available and anybody can log in and have as many users as they like to get in there is because of the wonderful fellows that I've put up on the screen there today. So we have these organisations donate their money and time to keep us running as an organisation so that we can keep delivering some training and get it available for everybody. Some of the quick questions: you can have as many individuals on your company account as you like. You can set up and access all of the resources for free as many times as you get them. The system will track everything that you've attended. So today I'll be marking the roll in there. It'll say you've attended this event. So if you go back into your activity history, you can always have a look at things that you've previously done. And if you've done work with us before, you don't have to redo it if somebody else asks you to redo the same work. So it's a bit of like an online school that's always available. So you can always jump back and have a look at something you've done before as well. If you have any other questions, please wait till the end. I'm quite happy to stick around and answer questions for you. Or you can drop me an email. I'm quite happy to get back to you. So that's just me briefly in a minute. Caroline.
Fantastic, thank you. And now to Caroline Noller, who is the CEO and founder of the Footprint Company, and they produce the Green Book. And Caroline has been a great supporter of Architects Declare since we started, and has been instrumental in leading the work group on developing up this guide, because who knows what embodied energy is, and how do we, what does a reasonable amount look like, and what does, how do we make it better? How do we reduce this? So I'm not going to say any more, but I'm going to introduce Caroline and say thank you so much for all your work on this. It's been fantastic.
Thank you. Thanks very much, Caroline. Thanks, Hayley. Hi, everybody. It's a pleasure to be here today. And as Caroline said, we've been working with you guys for a little while to try and develop this guide. In looking through all the faces and all the names, I know there's a number of people here today who may have seen some of this. I think the thing I want to actually sort of say is we've just recently updated this because the last 12 months there has been a massive acceleration in activity globally. It's sort of like really surprised me about how quickly momentum is gaining and exactly where things are at. So out of today, I'm hoping that you'll take away a little bit of knowledge about essentially just, being really clear about exactly what embodied carbon is, how does it occur over the life cycle, the distinction between operating carbon and embodied carbon, and then some key strategies around understanding what is net zero, how could we do it, how big is it, what's the challenge in that, and then some key strategies. And we're sort of going to go up in the helicopter and then down right at the material level to sort of also bring in stuff around how do we understand benchmarking of materials individually as well, and some of the work that's going on in the supply chain school in Meckler and a few other areas at this point in time. I do have a croaky voice today, so please excuse my croakiness. I'm going to share my screen. I think.
Can I just mention, Caroline, that this guide will be available on the Architects Declare website in the next couple of days as well.
Oh, wrong way. All right.
And this talk will be on the Supply Chain Sustainability School and also Architects Declare, I think so. It'll be available.
Look at that. Fantastic. Okay, so the first thing we really want to cover is really just trying to define the difference for everybody between embodied carbon, materials carbon, and operating carbon. And to some of you, I'm sure this is quite clear, but in putting this together, I think Caroline Pidcock has really helped to bring this particular picture to the front here, because from a visual point of view, it, I think, articulates and visualizes very quickly and easily to understand the distinction between operating and embodied carbon. We obviously have operating carbon. We all know and love embodied operating carbon, often known as scope 1 and 2, electricity, gas, etc. And that happens every single year across the life cycle of a built asset. And then we have embodied carbon. And we have embodied carbon that occurs in a couple of different phases. We have embodied carbon in the materials to make the building to practical completion. And then we have what we call replacement or use embodied carbon that occurs as we go through the asset life cycle. And that can be just to maintain that asset yearly. It could be to replace things after they've finished their life. Carpet, for example, at 10 years, paint potentially at 5 years, and so on. So just to get really clear, what we're going to be talking about today is the light blue, the embodied carbon phase. So when we talk about the definition of exactly what is embodied carbon, technically, embodied carbon is the coalition of all of the direct energy inputs as well as the indirect energy inputs to, facilitate the organisations that make the materials, and basically from the point of extraction of those materials all the way to their point of installation in the building. So from, some people would know, cradle to gate. Some of you may be familiar with the product phases A1 to A3. So in this particular picture, we've sort of broken the embodied carbon phases up into what we call upfront embodied carbon, which is where we say from cradle to finished in place, doors open in the building. And then obviously, as before, we sort of said, well, there's also this thing called replacement carbon. There is a scope of carbon at the end of life. What's really important to understand about the end of life accounting for embodied carbon is that you sort of have to separate that out, because you can't there's a double counting problem if we claim at the end of life, but also if we're purchasing recycled materials to the upfront side, you can get this double counting problem. So I'd like everybody just to focus on what we call basically the embodied carbon upfront, which is these two phases of upfront plus material use. So sorry, I'm going to go back over that. So embodied carbon from cradle to finished in place, and split up into two different key phases, which is our upfront and then our replacement use phase. What has happened over the last 12 months, a lot of work done in the UK and through the Green Building Councils here in Australia and the World Green Building Council, really to try and bring together a better, more seamless language around embodied carbon. So what's now being sort of defined and adopted around the world is we're splitting embodied carbon into upfront carbon, which is this phase here, which is cradle to practical completion, and then the use phase carbon, which is the replacement carbon. So whilst I'm operating the asset, the sum of those two is now what is called embodied carbon. So these are terms that, thankfully, we've sort of gone, right, here internationally is how we're going to describe these things going forward. So now hopefully we've got clear embodied carbon, and it's distinct from operational carbon, and that embodied carbon has two distinct phases to it: upfront and use. And when we think of the definition of that and looking at global emissions and accounting for global emissions from the demand perspective, then one of the things that has mercifully become also very clear over the last 18 months to 2 years is the recut of the way the global human emissions pie has been aggregated, so that we are starting to really sort of look at exactly, for our purposes as architects, how are we demanding, our demand for materials, how is it forcing the pie chart of global emissions? So this particular chart is now giving us a bit more clarity around the orders of magnitude of operating carbon to embodied carbon, materials carbon. And so really this particular reframing of the pie chart like this, I think, has really crystallised action globally, apart from the climate emergency, obviously, around exactly, well, why is this such an important issue that we need to get on top of? So you can sort of see here, essentially, when we look at all of the different industries, all of the different process energy, a whole bunch of different energy exchanges and business exchanges, we sort of see that materials carbon is actually significantly larger than the 10% that was previously understood, because that was really just looking at the process of construction, not the materials necessarily themselves. Global momentum is growing, which is really quite impressive to see. I'm sure some of you have been privy to newsletters and all sorts of stuff happening in the last 12 months. In particular, in Europe, Denmark has just recently announced regulation of embodied carbon quotas for new construction, commercial, and then mandatory measurement for residential construction. Denmark, France, and the Netherlands have all adopted those particular stances. In the UK, we've seen the London Energy Transformation Initiative, LETI, working with the Royal Institute of British Architects around a definition of how much, benchmarking and the notion of quotas for targets for whole buildings by a certain date. The Royal Institute of Chartered Surveyors has got an updated, what we call best practice method of measurement for embodied carbon for buildings, and Deo will be talking after me a little bit about the book that is being and the guide that's being authored, which essentially is basically looking at taking that, adapting that RICS best practice guide for Australia, so that it gives us very much the opportunity to use it as a guide here for Australia, so we can start measuring all our buildings consistently. Also, there's been the International Cost Management Society has also got another best practice measurement guide out for consultation, as well as a building code Z, section Z, which has also been promoted in the UK for embodied carbon for buildings as a building regulation, akin to the energy use intensity targets that we're all familiar with in operating carbon areas. North America, the American Institute of Architects have got a series of targets, and their targets are framed in terms of percentage reduction from average practice. So then the question is, what is average practice? And obviously, there's a lot of action sort of around in Australia looking at, well, how can we do this? What are benchmarks? So the work that MECLA, which the Supply Chain School is participant of, is very much focused on exactly, well, what are average benchmarks? And then also Deo's guide has also got some expression of some benchmarks that we've also contributed to. So an awful lot of global momentum, and I expect that we will sort of see embodied carbon very much quotas and limits being part and parcel of our workflow and requirements for DAs, certainly within the coming 18 months to 2 years in this country. This slide just really gives you a summary of some of those targets that I've just sort of spoken to. in terms of time frame around exactly when we think this concept of net zero for embodied carbon will be achieved. We can have a look at all the different organisations here: Architects Declare, American Institute of Architects, Royal British Institute, World Green Building Council, and even the Australian Green Building Council coming out with a 2030, actually a 2030 net zero, I think, is their target that they've just recently announced. As I said before, the American Institute of Architects have said essentially we've got to get this 40% reduction from average practice now, moving through to 65% by 2030, 100% net zero by 2040. The REBA targets and LETI targets, they've just sort of really recently changed, which is really about the expression of embodied carbon targets by certain dates in physical quantities: 100 kilograms of CO2 per square metre, 500, etc. And those numbers are coming up a bit later. So in terms of what we call a net zero embodied carbon building, the current definition that is being adopted is basically one that it's a building that achieves essentially the highest levels of materials efficiency initially through the rigorous application of circular economy principles, and then starting from a starting point, reducing it down through using those reuse, adaptive reuse principles, recycling, low supply chain, etc. So applying those principles to get a residual amount. Certainly in the experience that we've got in practice over the years, we don't see at this point in time, today, 2021, that a pure net zero is a plausible thing. There will always be a residual. But having said that, by 2030, who knows? We may well have the materials supply chain have evolved itself to the point where a true net zero, just through low carbon supply chain, net zero carbon supply chain, is a plausible thing. But until that time, we'll generally have a residual amount. And so then the net zero then becomes the netting off, the purchase of or achieving of on-site or off-site credits to equal the residual amount, essentially gives us our net zero. There's certainly a lot of talk at the moment about, is the term net zero correct or carbon neutral? And there's certainly work being done in a couple of areas in Australia at the moment to come up with a definition of, is it net zero, is it carbon neutral? In terms of the logic of it, there's a couple of different ways you can offset. You could choose to essentially offset 100% at practical completion, go out and purchase those credits up front to extinguish your residual. That's one methodology. And then the second methodology is to also then say, well, I have a practical service life, 10 years, 20 years, depending on the physical asset. Is it an office building, is it a house? But if you then choose to annualize that residual over that service life and then offset it on an annual basis, the thing to be aware of is that you really want to then get into the point of then accounting for your use phase embodied carbon as well, and adding that to your offset requirement. So the accounting for that gets a little bit more tricky. And from a project circumstance perspective, it also becomes the question for you as a practitioner to say, well, what is in my control? Can I work with my client to offset 100% upfront, and then they can choose to look at the offset further down the track? Or do I use it as a way to engage my client with different design solutions? So it's really a choice at the end of the day about how you want to pursue that net zero. We're working on a few projects at the moment where definitely it's like, okay, within the sphere of our capability, we can look at the control of netting offset, net zero upfront to practical completion. So this picture really is just giving the construct visually of sort of saying, here's my starting point. I apply these principles. Can I reuse, adapt? Can I optimize my design efficiency? Can I use recycled content materials? Can I use alternative low zero supply chains to come to a residual? And then I can choose to annualize that and then purchase offsets 100% year one, or I could basically continue to purchase and accumulate that offset through to a fixed period of time. So in terms of what I was sort of speaking to before, when we talk about looking at, well, minus 40%, minus 65%, I mean, when we look at, I guess the global consensus is typically at this point in time, a 40% reduction from current average practice is sort of the zone that we want to be looking at today. And I think jumping straight in to do a whole building is obviously a big challenge. So all I'd sort of say is for everybody on the webinar today, perhaps even just try and consider just every individual decision that you take, whether it's looking at floor finishes or walls. If you've got in the front of your mind, each decision I want to take, I want to be looking for a material or an assembly solution that at least gets me a 40% reduction. Then I'm on my path. I'm on my way to start to implement practice in this place. So in terms of then really trying to get a hold on exactly, well, what is average? How big is embodied carbon? How big is it? How much embodied carbon is there in buildings? I think it's been very confusing for many people over the last 12 months because we have had many publications, many targets and benchmarks published out of the UK, out of America. I think what's been very interesting as a practitioner in this area for 20 years or so, that there are a number of key variables that are really important to understand in terms of trying to compare exactly how much embodied carbon is in an asset. And so what's really terrific to see with the RIBA, the Royal Institute of Chartered Surveyors, DAO's guide, is about sort of saying, well, we haven't had very good guidance through a couple of standards that currently exist for us today to get consistency. And that's why basically the international community said, you know, some of the standards that we have been using over the past few years really haven't assisted us to get consistency and comparability, which is a shame because the foundation standards that underpin embodied carbon assessment, which is the ISO 1444 life cycle assessment, the whole purpose of it is to get consistency, comparability. So when we talk about a whole building, we're talking about all of the elements of a building, all of the structure, the foundations, all of the envelope and facade, all of the internal walls, surfaces, finishes, fitments, etc., as well as the cost of the builder's building process, the preliminaries, if you like, and then all of the external work. It's very important that we look at all of these elements, not just part of it, because there's been an extraordinary number of publications just looking at some of the building materials that are really, really easy to measure. So generally, structure and facade have been typically the things that have been measured historically because, you know, it's pretty easy to account for your concrete. It's pretty easy to account for your steel. It's pretty easy to account for your window areas, but it's much more difficult to account for all of your internal walls, all the elements of your services, the square meters of ductwork, the linear meters of cabling, the light fittings, the number of plumbing fittings, the amount of fitments and joinery. And so what we've seen is a very extraordinary incompleteness in global publications. The chart here essentially is work that we've done in our practice and also with working with DAO and the guide that he's putting together to essentially look at, well, all of these projects that have been measured in a consistent manner and this is Australian numbers here, so we should have probably marked that. These three here are Australian numbers. These two here are UK figures. And then we have a couple of global studies that have been done who have basically pulled together many international publications, really, and we've sort of tried to stack them up against each other to sort of try and really highlight this point of completeness and comparability. So if we have a look at this particular starting point here, class 1, so this is class 1 residential as we know it, single houses in Australia. This data here is drawn from our database and our calculator, the footprint calculator that we've been running with in Australia for the last 10 years with a huge number of projects and developers, measuring everything in a consistent way. And we know with class 1, and this This is really the range of double brick to timber. We have a range. You can see this bar gives us a range that goes from sort of something like about 800 kilograms of CO2 per square metre of net floor area all the way up to sort of 2,800 in a range. So the average value for us for all residential class 1 is sort of around that 1,500. And you can sort of see basically then where is it by the major elements. You can see here the orange is our structure, the yellow is our facade, green is the internal walls and finishes, services, and preliminaries and external works. Office buildings class 5, similarly, you can see the order of magnitude and the proportion of the elements to the total and the average in the span. What's important to see here, a couple of points to make. One is this is our class 1. Then LETI figures came out last year, and essentially they were proposing numbers as low as 1,000, but they were incomplete. They've just rephrased these and actually republished these. And these numbers have actually gone to about 1,400 kilograms of CO2 per square metre, so not inconsistent with our figures. And the targets that the LETI team are going for are much tougher, because generally speaking in the UK, they have much more access to very efficient low CO2 supply chain as compared to here in Australia at this point in time. So one of the most important things really, I think, in terms of starting your journey is basically understanding what's my class of building, how many square metres of net floor area do I have, where is my proportion likely to be on an average basis for embodied carbon. As I said, these slides are a good part of the guide to help you. These are going to be published. You can refer to them. We obviously run an information source called the Green Book, where we have all of these types of benchmarks. I know some of you who are on the call today here are already subscribers and are already using this, and I'm hoping this is really helping you in terms of understanding where's my starting point, where are my big moves, where is my carbon, which element of the building should I really be focused on as your starting point for what do I do. So we've sort of talked a little bit about benchmarks, understanding when you're looking at a benchmark, you want to make sure it's a local Australian benchmark, that you're not going and grabbing a REBA or a LETI number and trying to apply that target here to Australia, because regionally the targets are averages are very different. Then from a building class point of view, it's very important to understand that buildings are very different based on their class and also their standard. Even within, for example, class 5 office buildings here in Australia, there is a very big difference in embodied carbon between a suburban office building and a premium high-rise, Barangaroo, Sydney Tower, the top end of town. Very big difference between them. So when you're going to start on this journey, it's really important that you first look for, where am I at? What type of class? Have I got a subclass in there? So what should be my starting point? And then where is my carbon in terms of structure, facade, services, etc. And they're really, one of the most important things I think is really important to consider is that certainly in the experience that we've had, the early stage of the design process, feasibility to early stage, potentially into your concept design, it's your biggest opportunity to avoid carbon and mitigate. This picture really tries to give you a bit of here's your design phase. And then we've sort of really tried to encapsulate in some simple bite-sized sort of concepts where you should be looking from a design strategy point of view. So certainly in this master plan early phase, then your opportunity to ask that question, build, no build. Do I have an existing something on my site? Can it be reused? Can it be adapted? What can I do with it? Can it be retained, reused, crunched up into little pieces and put back in? What can I do? And certainly this question is really important. We've been involved in a number of projects over time where the initial scope was knock down, rebuild. But time, cost constraints really saw that the build to the retain and adapt actually became a really efficient alternative and was integrated into the solution. And so I'd really encourage you all to look at that. And you can give yourself a 0 to 25% improvement by potentially challenging the question of build, no build. The other question here is also that question of right sizing, very much this early phase of exactly, how much services am I going to be providing? What is my watts a square metre? How is that translating into electrical infrastructure, mechanical infrastructure? What is my selection of those type of servicing? Can I improve my floor-to-floor height and block and mass, etc.? So these become really important strategies to pursue. Then really the optimised systems dematerialising at that next stage of design, and certainly in this early stage concept. One of the things I will say is that if you start to apply this embodied carbon and operating carbon, there is a very important thing to start to think about, which is that the current approach to Section J envelope is very much driving up embodied carbon in facade. So it's a really good opportunity here at this point in time to essentially apply a test of embodied carbon to operating carbon to ensure that you're not actually running away with upfront carbon. We've seen this phenomenon occurring in residential construction as you go towards that really high operating energy efficiency, you're often adding more carbon than you're saving. So I'd really encourage you all to look at starting to use the concept of embodied carbon assessment and use carbon assessment and doing simple payback analysis of certain elements to ensure you're going in the right direction. The design smarter, looking at your elements, and we'll go through a couple of different elemental systems as a simple strategy. And then looking at, post-tension structures are more efficient than conventional structures, looking at how efficient your structure is. This is very much the zone of how do we dematerialise. And I think the thing about embodied carbon is also as you get more design efficiency, your costs generally reduce, which means that in most cases, in our experience, you're seeing as you're chasing out embodied carbon, you're chasing out costs. Speed panel is a really classic example of that. I've got a little picture of it coming up in a couple of slides, but I think that it really demonstrates the point of a more efficient system. Rytec walls, ready walls, tin cell walls, some of you would know those things, single wall. I mean, those things have been adopted significantly in the commercial residential construction industry because they tend to be cheaper and faster. And generally, if something is cheaper and faster, it also has less embodied carbon to it. The supply chain is a very specific thing about materials supply chain, my no carbon, low carbon. I think really you sort of at that at the end, very much looking at this end of the design process where you're really down at that procurement. I'm going to be buying Boral concrete or Holcomb concrete. That's in that sort of area. I think one of the key challenges that exists, certainly has been existing with the way that some of the other calculator tools that are being used around the world is they're very much driven just on the EPDs alone. And that becomes sort of sometimes quite difficult to being applied at the early stage process. So very much looking for how do we accelerate at this early stage. And then you're looking at, well, how do I make sure I've got my, my bib and braces on at this, at the other end of the supply chain, at the procurement end. So then what we're going to do is now just sort of quickly have a look at that particular question, as I just sort of talked about. One of the key challenges that we've been faced with in terms of trying to accelerate practice, although we're getting an enormous number of product declarations coming out, the industry has sort of also understood the challenge of comparing how comparable are individual EPDs. And it looks like sometimes they're not very helpful to you as a designer at that early stage. If we just go through the example of brick as an example, if you were to pick up a couple of different EPDs or product declarations that exist in Australia at the moment, brick is often presented to you in embodied carbon per kilogram of brick. But the challenge for us as designers is, well, what do I do with that? Because I don't know how many kilograms of brick I need. And then depending on the type of brick you have, standard common and metric common, you have different amounts of kilograms per individual brick. And so in this case, a metric standard brick, we've got about 1 kilogram of carbon per brick. And then we sort of think, okay, well, how many bricks do I need? Then we want to be thinking about, well, in actual fact, as a designer, what I need to know is how much carbon's in a square metre of a finished brick wall, because that's the thing I'm designing. So then if we look at, well, once we put that brick into a wall, we need about 52 bricks to get that 1 square metre of wall, plus with a bit of waste. Then I need some mortar to put it together, depending on how I'm going to do that mortar. Do I render it? Do I put plasterboard on it? If we just look at 1 square metre of one skin of brick wall, then I've got about 77 kilograms of CO2 for that 1 square metre of wall. But then is that good or bad? I don't know, because I don't know. I have a half dozen different opportunities for walls, and I'm really looking at, well, which wall system is my best bet? And so you can sort of see here, well, here's what I'm being given, but this is sort of this is where I'm starting to look. So I really still don't understand, is brick good or bad? So then if we have a look at different types of walls, and these walls are all 60-minute walls, we have a continuum from typical steel framed 94 steel framed, insulated, 2 layers of fire check either side, or we could look at a hollow concrete block wall. I've got my single skin of clay brick wall. I could be looking at a 100 mil aerated block wall. I could be looking at timber framed wall with insulation and plus fireproof plasterboard, or I could be looking at a 78 mil thick speed panel. The embodied carbon of the finished assembly is here at the bottom. And if we are sort of taking that theory of, well, what's my average wall then for this particular sample, our average point here is about 68 kilograms of CO2 per square metre of finished wall. And then if we were to sort of go down that path of saying, well, okay, now I need to be thinking about what's 40% less than that to be an efficient low carbon wall, then my number is sort of down here at this sort of number, around 41 kilograms of CO2 per square metre. And I can sort of see basically on the selection continuum of virgin product, then my options are a little bit skinny. But if I was to, then think about, well, what happens if I have a reclaimed brick wall? Then, well, obviously my reclaimed brick wall would come from here, probably down into this zone here. And if I had potentially fully recycled galvanised steel framing and some content of recycled plasterboard, then I'd potentially be sort of somewhere back down here. So it's one thing about sort of saying, well, what is the average from our standard type of material? And then I can be looking at, well, where should I be looking for an efficient system today based on average materials? And you can sort of see this is the type of thinking we want to be looking at. So some of the work that we've been doing with MECLA, the Materials Embodied Carbon Leadership Alliance here in Australia, is to try and start doing these types of activities for materials so that we can sort of basically understand, well, for a group of materials, which one is my low carbon individual material, and then how does it come together in assembly? So here's a picture looking at just the individual material itself. So we looked at brick, but then we've looked at the different wall assemblies. Now let's just have a look at concrete itself. So we've got a 32 MPa ordinary Portland cement mix here in Australia. We have a number of generic industry sources. There's some generic industry assessments that have been done. We have a number of high quality peer-reviewed academic what we call inventories that we can access. And when we look at averaging all of those data points for 32 MPa concrete, we find a current average value in the order of 356 kilograms of CO2 per cubic metre of concrete, ready mixed concrete. And then if we apply this concept of a 40% reduction, and we give it a little bit of a plus or minus 5% for a whole bunch of different uncertainties in accounting methodologies, then we sort of see this yellow band here, this horizontal yellow band, as being the definition of above is not where we want to be, but below is where we want to be. And then we've basically lined up a bunch of different actual products that all have product declarations to just have a look at, well, you know, have we got any options at the moment that would define low carbon? And we can sort of see there are a number of them that sort of fall within generally that order of magnitude within that 40% line. Some of them above it, but obviously all below the average. And then if we take our 65% line and sort of say, okay, well, we want 65% reduction by 2030, who's going to make the cut? And obviously geopolymers are different. They're not ordinary Portland cement, they're cement replacements. But it's interesting to see the potential of geopolymers in concrete as a solution that would define low embodied carbon. And all the difference in between. So I'd encourage you to also sort of keep in touch with MECLA, because this is sort of a lot of the work that we're trying to get out and about through the supply chain school in MECLA for all the different types of materials to help accelerate your ability to understand and to pick up a material and say, okay, well, at least I understand this is in that low carbon realm. Okay, so we've sort of been up in the helicopter where all the targets, 40% is where we're wanting to head. Where is it from a strategy point of view? What are my big ticket items that I should be looking at across my design phase? Thinking about how would I look at efficiencies and what is a efficient assembly? And then how could low embodied carbon materials or even recycled content materials, and sorry if I do actually go back, one of the things that I think you can sort of all see, some of you have been very familiar with the fly ash replacements, the concept of using recycled material into as replacements in materials. Then these are materials that are using that recycled content. So it's using those circular economy principles. Very quickly, now I'm going to just scoot through a couple of just one quick little case example of exactly, well, how big. If we wanted to offset a typical residential house, we're going to basically design a 200 square metre brick veneer home, and we're going to build it in Australia to typical average design. Then I'm going to have something about 350 odd tons of CO2 in that average brick veneer. I'm going to apply my principles. I'm going to be looking at recycled materials. I'm going to be looking at efficient design. I'm going to be able to achieve my 40% embodied carbon reduction. And then I am going to be left with about 228 tons of CO2. I'm going to basically say, well, I'm just going to offset that, but I'm going to offset that annually for 20 years. So I'm going to slice that up into 20-year pieces, which means I have to sort of be looking at, ignoring my replacement carbon, about 11 tons of offset that I'd have to get each year to be able to achieve that. And so if you're in New South Wales and you're able to put over 30 square metres of PV panel that were operating perfectly on your roof of that same house and keep them operating perfectly for the next 20 years, then that's going to be the order of magnitude for you to offset that on site. If you were going to do a similar sort of thing for a class 5 office building, then you're going to need an area something like the area of the Sydney football ground or Melbourne cricket ground, actually 1 hectare of PV panels. So, at the house level scale, it's going to be potentially possible for you to do an offset on site. Otherwise, you're going to have to go and buy offsets. In our commercial size developments, it's going to be really hard to achieve that on site. I think for me, what's going to be interesting is in the shopping centre world, where we are seeing massive rollout of solar panels all over shopping centres. And as our grid greens, it means that the output of those panels could actually be potentially redirected into offset embodied carbon as opposed to operating carbon. I've got 2 more slides and then I'm going to be actually out of voice, I think. In terms of just resources that are at your disposal and just a smattering of the resources that we've made available for you to think about. In terms of design information, so you've seen some facts and figures and some information in this presentation from me. That's both from our product, the Green Book, but also there are a number of accessible inventories, the AusLCI from the ALCAS team, We've got a circular ecology, which is a UK information. You've got a couple of different data sets here. You've got the Melbourne University EPIC database, Gabi database, our one, the Industrial Ecology Lab, and University of New South Wales also has a embodied carbon database. These all have different types of information in terms of individual materials and also assemblies. And then, as I said, in our resource, the Green Book, we've also got the whole building benchmarks. There's also lots of calculators. I want to call these not so much tools, but calculators that can help you model and assess and account for the embodied carbon. Some of you may be already familiar with EC3. EC3 is swallowed up tally, so they're going to operate together. We've got one called Cove Tool. Cove Tool basically is also, it will do your operating carbon footprint. Some of you probably use it already. We've got a link with Cove Tool to put the Green Book in there. They also have a link with EC3. You've got eTool. Some of you are very familiar with eTool. They have a little calculator tool for residential construction. We have a similar sort of product called the Footprint Calculator. Gabi is and SEMA Pro are also software tools. Some of you are familiar probably with One-Click LCA. And there's also a little one called the Carbon app on the Giraffe build. Some of you may use that as well. A little bit of profile about, who's web-based, who's basic, pretty simple, who's a little bit more advanced. I'm sure some of you are familiar with all those. And for those who aren't, I'd encourage you to have a look. I think we actually had the URLs for all of them, so we'll make sure that that goes onto this slide. In terms of your process, obviously you want to essentially at least start. I'd encourage you to have a look at DAO's guide when it is published, because it talks about that. How do you go about making the build, measuring your building? I'd encourage you all to think about starting to use some basic calculators, because it's important you at least start calculating some, if not all, of your buildings, because it's not until that whole thing about you can't manage what you don't measure. And so just even starting the process of accounting for the embodied carbon is a really, really important step. And as I said, some of you I think are already familiar with some of our tools, but it's certainly worth starting. And then the thing is really sort of commit yourself, as you have been as architects declare, set some targets, start to make at least just, I'm going to start to measure to find out exactly how much carbon is it in my building. I may not necessarily set a reduction target at this point, but certainly a lot of the practices that we deal with, we encourage you to think about starting to just measure a couple of projects that you're familiar with, just to find out how much embodied carbon is in the design style I like. And that's a really good first starting point for you to actually start to make some practice up. Eventually, and certainly in terms of DAO's guide and also with the Architects Declare, encouraging you all to at least start to measure and then getting on the bandwagon of reporting internally and externally. We certainly work with a few of our architect colleagues, large practices who have even made it just a core part of their design service, that when their clients purchase their services, then they're coming with a commitment of 40% or a 50% or more embodied carbon reduction. A little bit of extra reading I think is in here. And then otherwise, I'm sure there's lots of questions. I'm going to end my show now. Oops. I think that's ended my share.
Okay, thank you, Caroline. Wow, heaps and heaps. I think what we might do in the interest, thank you so much for that, but we might just go to DAO, and if anyone's got questions, please put them in the chat, and we might not get to them today, but we will see what we can get happening, get some responses later. But thanks so much, Caroline. And by the way, if anyone is interested in working with Caroline, I think she's looking for some design, people with design skills to help her in her business. So obviously it's not pure design, but I think getting that connection of design and numbers is really important. Okay, so quickly on to DAO. Thank you, DAO. DAO's been in this game for ever since I've known him, but more recently sort of getting very specific. So, and he's about to release a book. So over to you, DAO. Thanks.
Thank you, Caroline. And that was a masterclass presentation from Caroline Noller on embodied carbon. I think if you were to understand the topic and relate it to what we're trying to do here, that was quite a masterclass. What I'm doing, I'm the sidekick today. I will just talk broadly about how it connects to some other work we are doing. And Caroline Noller, myself, Phil Oldfield, Landing, Malay, and Aisu, we got together with a post-CRC low carbon living grant to put together some documentation which is going to address net zero carbon in buildings and built environment more generally. But many of the roadmaps and things were very much aspirational. And 2050 was thrown about a lot as an aspirational goal. So we decided to look at more science-based and say, okay, what can we deliver during the shortest period of time, and 2030 was on our minds. So what we did was to look at not only a climate emergency situation, but also how to communicate some of this information, which includes what Caroline has been talking about in detail, and also operational side. So on a whole of life basis. And what we came up with was, so looking at two things. One is a book, which is about 280 pages or so, which has a lot of details and exemplars and policy that drives this and so forth. But a 30-page guideline, which is a summary, which is the reading span of a professional in an office, I guess, with a few things that they can cut out and stick on the wall in front of them. And this includes how to navigate through best performance, through on-site generation, through offsets to a net zero carbon situation. So that's the book and the guide. The guide is going to be available widely, freely, and it will we'll talk to Hayley and of course Caroline and others to see how it can be made available to those who wish. And the book would be Macmillan Palgrave. So that's coming out. But we put it also in the context of broader sustainability discussion. So you don't just look at one thing, but put it in the context, because there are often trade-offs. So if you're looking at efficiency on-site versus off-site purchase, there are trade-offs. At a certain point, it becomes more expensive to go beyond a certain best performance on-site to the next level. And with reductions in photovoltaic costs these days, it may be a better option for offsets. But down the line, you have to look at all of it together. But we recognize there are existing buildings, and then there are new ones as well. So we look at a whole range of those. We looked at literature from Global Alliance for Building and Construction, which is the UN network, World Green Building Council, and Caroline's talked about REBA, LETI, and others, and looked at Australian targets and see how we can shorten it to 2030, and looked at what neighbors and road and Green Building Council, amongst others, were doing, and what the trajectory based building code changes coming up we're going to deliver. And we then put it into the context of how we can, through this guide, look at a whole of life approach, as Caroline described, and then see how we can navigate to zero. The key part of the operational side, Caroline talked about the embedded part. The operational part as well is made up of efficiency, how far through good design and systems we can go to best practice, then on-site generation and off-site. And there is a need for a client-designer conversation in all of this to look at where the trade-offs lie, and in terms of how much you spend on efficiency and how, at what point the offsets become more cost-effective based on what sources you're looking at. At UNSW, as an example, we have existing setups, some new buildings coming up, but we looked at what we can do on site, very limited roof areas, what we can do through efficiency and generation. But then we looked at a huge gap that was remaining to go to net zero carbon. So we invested. The university spent money on looking at offsite. There's a photovoltaic power plant near Mildura, which is where we get our offsets from. So we know where it's coming from, and we have an intermediary we go through, and we generate. If you look at the graph there, our total demand changes between day and night. So base load at early in the morning when the students are not there, and we generate enough during the daytime on average to offset the nighttime demand through photovoltaics. UNSW, as you probably know, is world leader in photovoltaic research. So we went via photovoltaic research. In actual effect, about 70% of world photovoltaics on roofs come from research done at UNSW Center for Photovoltaics. So that's pretty significant. What we did was also go through a power purchase agreement. So what we ended up doing was look at a economic outcome, not just an environmental outcome, through a 15-year power purchase agreement for a project this large, a campus this large. It was the cheaper option for us to look at photovoltaics and not the normal grid electricity. So it was cost effective and economic at the same time. So the pathways to zero can be done in a much shorter time. Many of us, including myself, live in net zero operational carbon building homes at the moment because it's the cheaper option in any photovoltaic space in 3-4 years these days. So we looked at the whole building stock in Australia, different climates, different ways of building in different parts of the country, and for different building typologies according to the BCA. We looked at the top-down approach and a bottom-up approach to how we deliver on this, including offsets, and came up with, for different building types, from best practice, in other words, the energy use intensity that we can achieve, what is current today, and how we can progressively reduce them to a level where on-site generation and offset can actually deliver. So these are well calculated, and we have it for different building types as well. And we set a challenge basically, and this is a diagram we actually like a lot after Malay came up with it. We from 2021, how can we navigate, and we set different targets for different building types, both and also operational and embodied, in terms of offsetting. And trying to deliver net zero by 2030 and net zero embedded by 2035, hopefully, but 2040 for sure, through mechanisms like what Caroline earlier described. So this is feasible. The guide will contain a lot more information on what and how, and exemplars in the books and so forth will describe exactly how best we can do this. So this is all, and there's a lot of information freely available on websites like the Low Carbon Living website on low carbon design, retrofits, and new and old and all that sort of stuff. And hopefully you can draw from that and use as much of that as possible. So thank you.
Thank you so much, Deo. That's fantastic. I think we're all dying for this book to be published and looking forward to it a lot.